right, we're going to do some application problems here. So I'm going to use my graphing calculator. I have a TI-84 plus. We're going to use regression to find a quadratic function that models the data in the table below. So I'm going to press the stat button here to edit, and then press enter to edit my list. And I'm going to enter in the X values for list 1. So you take 0, press enter, then you enter 5, enter 10, enter 15, enter, and then 20. Okay, now once we've entered in the X values, then we're going to go to the right in list 2 and enter the Y values. So we have 0.2, enter, 0.38, enter, 0.68, enter, 1.4, enter, and 2.2. Okay, now at this point, we're going to go back to our stat button here, press that again. And now we're going to use the right arrow to go to the calc column, and then we're going to enter, we're doing a quadratic regression here because we're looking for a quadratic function. So we're going to enter 5 for quadratic regression. And then we're going to go down to calculate, press enter, and it'll give your values for A, B, and C. So we're finding that the function that models this is going to be f of x equals, and I'll just round it to the thousands place. So we have 0.005 x squared plus 0.006 x plus 0.205. So here's the function, the quadratic function that models the table. Here we have a ball is thrown off of a building, and the function h equals minus 16t squared minus 10t plus 200 can be used to model the height of the ball after t seconds. How long does it take for the ball to hit the ground? So I'm going to go ahead and type in my function here. You're going to select y equals, and then be careful, don't select the minus sign here. You're going to use the negative sign, which is right here. Okay, so it's going to be negative 16 x squared, and then now you can do minus 10x, and I'm using x instead of t, but same function, plus 200. All right, so I could use the quadratic formula, but I did a couple examples already using the quadratic formula, so I thought this time I would do it using my graphing calculator. So once you get your function in, and you want to find the intercept, so you're going to do second function trace, which is going to give you a list of calculations, and we want to find when is the function 0. So we're finding the 0 for this function because it's how long does it take for the ball to reach the ground, and at the ground level the height is 0. So we're going to plug in 0 for h because we want to know what is the time at the ground level. So minus 16t squared minus 10t plus 200. This is the equation we're solving. So basically we're finding the zeros of this function, and I put the function in, and now I'm going to select 0 to find the zeros and then press enter. But what I need to do first is I want to get a better window here. So I'm going to change my window, so my viewing window. So I'm going to select window, and the height is dropped from 200, and I'm guessing for it to fall, it's got to be less than 5 seconds. So I'm going to say my X min, the minimum time I'm going to say is -1. You're not going to have -1 seconds, but I just want to be on the other side of the axis. And then I'm going to go and, whoops, I didn't want to do that. Let's see here. Okay, then, let's see, -1. Make sure you don't select minus, but do the negative symbol. This one, -1, is what I meant to say. And then for the max, I would say 5 seconds is enough for it to fall 200 feet. That's my guess. So I'm going to put 5 in here. And the scale for 1 is fine. Then the Y min, I'll just leave it at -10, but the max is going to be 200 because, or let's say 210. And because we're dropping it from a height of 200. So, and then the scale on that, let's just say 25. That should be about right. So now I want to graph it now that I have my window. And there you can see the parabola. Oops, sorry. There you can see the parabola. So the ball is dropped from a height of 200 and it falls. And then the x-axis or the t-axis is the horizontal axis. Here's 1 second, 2 seconds. Just after 3 seconds, it hits the ground. And so we want to find what is that x-intercept. So I'm going to go second function calc, and I want the 0, so I'm going to select 0. And now I've got to do a left bound. So you can see there's, if I follow this path, there's going to be an intercept over here somewhere. I don't want that one. I want the one, the positive one. So I'm going to set my left bound at 2. That's fine. And then my right bound, I'm going to make, let's say 4. Okay. And let's see, trace. Oh, I want second calc. I want the 0. That didn't work very well, did it now? Let's say left bound 3 and right bound 4. Guess. All right. You can see now that I get 3.23. So X, or in this case, T equals 3.2, well, 24 if you round up. Because notice that that's the 0, because notice that the Y is 0 here. And so you've got to put a left bound and a right bound in so the calculator knows not to look at for the 0 that's over here, but to look for the right 0. So you say X equals 3, X equals 4 are the boundaries. And then the actual value, the 0 is 3.24. It's in between those two boundaries. Okay. Finally, in this next problem, so that's how long it takes for the ball to hit the ground. And in the next problem, we're going to make a line graph of the data in the table, and we're going to find what is the minimum degree of F and the leading coefficient, positive or negative. So you're going to do a scatter plot. I'm going to go ahead and clear out my data here. So I don't have any, sometimes if you don't clear out your data, it'll mess up your graph. So I'm going to go ahead and enter in this data. So I'm going to select stat, edit to do the lists. And the X values are -3, enter, -2, enter, -1, enter, 0, enter, 1, enter, 2, enter, 3, enter. Okay, I've got the X values. Now the Y values are negative, remember to use the negative button, -15, enter, 0, enter, 3, enter, 0, enter, -3, enter, 0, enter, and 15, enter. And I want to adjust my window. So the minimum X value is -3 and the maximum is 3. Let's just say -4, 4, so we're not right to the edge of the window. So I'm going to say -4, 4. We'll keep it at 1. The Y minimum is -15. And the Y maximum is 15. And we'll say the scale, let's go with 5, or 2, let's go with 2. All right, now we're going to graph, or we're going to do a stat plot. So second function stat, right there. And I want to turn on the stat plot. So I switch it to on, it's off. You switch it to on by hitting enter, and then you're going to go back to your stat plot graph, and you can see right there, we have a cubic function. So it comes, there's one intercept, then there's a turning point right here, then another intercept, and another turning point. So you can see the type of, the graph is cubic. All right, and there are 3 x-intercepts, and they are, it says state the minimum degree of f. It has to at least be 3, because if you have 3 intercepts, that's the minimum that your degree can be. So it's at least 3, and the leading coefficient you can see is positive because the end behavior shows it goes down here and up, down on the left, up on the right. So the degree is positive. And then we are asked to find a formula. Now, when you're looking for a graph of this, you need to do a regression for a cubic function, but you got to get rid of your stat plot first. Otherwise, it will not work. It won't graph it for you. But first, let me go ahead and answer these questions. The minimum degree is 3. The leading coefficient is positive. And to find a formula, we're going to do regression. I'm going to turn my stat plot window off. Okay, and then I'm going to go to, I just want to see a graph. It's not working. Probably because my stat window. All right, never mind. We don't need a graph. Let me go to back to the stat here, and we're going to go over to calc, and we're doing a cubic regression. So we're going to do 6, and then we're going to go down to calculate, and you get A equals 1, B equals 0, C equals -4, and D equals 0. So our graph is f of x is equal to x cubed, that's the A, is 1 times x cubed. There is no x squared term. Then we have minus 4x, and there's no constant term. All right, so this is the function that we're looking for.